One thing that you want to note is that the coordinates r comma theta and negative r comma theta plus pi represent the same point. Let's look at the sketch below. So this angle here, it kind of looks maybe like pi over 6. I'm just estimating. And if I count 1, 2, 3, 4, 5. So let's say that that's 5 units. That means that this point is given by the ordered pair 5 comma pi over 6. Now, if we want to be on the same line segment extended in the other direction, then we know that this angle is going to be pi over 6 plus pi, which if you add those together ends up giving 7 pi over 6. And if we go in the positive direction, then we go 1, 2, 3, 4, 5. But if we wanted to go in the other direction, then we just need to make it negative. So this ordered pair here is going to be 5 comma 7 pi over 6. And if we wanted to represent this ordered pair in another way, this ordered pair would be negative 5 comma 7 pi over 6. So all this note is saying that these two things are equivalent and represent the same point, basically. And so these 2 points in this particular example represent the same point as well. Also keep in mind that because of the coterminal angles, each point has infinitely many representations. So the point r comma theta is the same as the point r comma theta plus 2n pi, where n is some integer, and also the same as negative r comma theta plus the quantity 2n plus 1 times pi again, where n is some integer. Example 2 says graph the ordered pair 2 comma pi over 4. Find two other polar coordinate representations where r is positive, and then another two where the r value is negative. So I'm going to go ahead and I'm going to draw my axes here. And I know that pi over 4 is along this line. So this angle here is pi over 4. And then if I'm starting at the origin, I would want to go out 1 unit, 2 units. And so I'll graph it in green. That is the ordered pair that I am looking for. And so I'm going to come down here. And so that is 2 comma pi over 4. Now we want to come up with two additional ones where r is positive. So all I need to do is I need to add 2 pi to pi over 4. So I'm going to do pi over 4 plus 2 pi, which is equal to pi over 4 plus 8 pi over 4. And so that's going to equal 9 pi over 4. So another ordered pair would be 2 comma 9 pi over 4, and that would represent the same point as 2 comma pi over 4. And then I'm just going to add 2 pi again, and so that would give me 17 pi over 4. Okay, so now I need to find two ordered pairs that have a negative r value, and I know that both of the r values would need to be negative too, because that's how much I'm walking out. And previously we saw that for the angle, we just need to add pi to it to get us here. And then if r was positive, then we'd walk in that direction. So we need r to be negative so we can end up at this green point again. So this angle that I have in green is going to be pi over 4 plus pi, which is 5 pi over 4. So 5 pi over 4 would go there. And then I need an additional 1, so I can get that by doing 5 pi over 4 and adding 2 pi to find a coterminal angle with that. And that would give me 13 pi over 4. So here are all of the ordered pairs that represent the same point on our plane. Next, we're going to be talking about relationships between polar and rectangular coordinate systems. To change from a polar coordinate to a rectangular coordinate, we use the formulas x equals r times cosine of theta and y equals r times sine of theta. To change from a rectangular coordinate to a polar coordinate, use the formulas r squared equals x squared plus y squared and tangent of theta equals y over x. Let's go back to the beginning of this outline to kind of illustrate these equations. So one relationship that we want to see in this right triangle here is the Pythagorean theorem. Note that we have a right triangle here. Let me use a different color. So we have a right triangle here, and the bottom length is x, the vertical length is y, and the hypotenuse length is r. And so just based off the Pythagorean theorem, we have the relationship that x squared plus y squared is equal to r squared. Now, another relationship that we can create is that if we were to take tangent of theta, we know tangent is opposite over adjacent. So our opposite is y and our adjacent is x. So we can come up with that relationship as well. The other two relationships is if I were to draw the unit circle, and I was at some point here on the unit circle, then this length would be 1, and this ordered pair would be cosine of theta, comma, sine of theta. And since we have proportional triangles, if we multiply the radius by r, then that tells us that this point here is going to be r times cosine of theta times r sine of theta. And so that's how we get that x equals r cosine of theta and y equals r sine of theta. So these are the 4 relationships that you want to memorize when we are converting between rectangular coordinates and polar coordinates. Let's go back down below in our outline. All right, so example 3 wants us to find the rectangular coordinates of the point -4, 3 pi over 4. So let's go ahead and find 3 pi over 4. We know that's in quadrant 2. Okay, so I'm just going to draw it. That wasn't straight, or that wasn't connecting to the origin. Okay, so 3 pi over 4 is this angle here. And if this was positive 4, then we'd go 1, 2, 3, 4, and then we would plot our point here. But because it's negative, we want to go in the other direction. So I'm going to extend my line down that way, and then I'm going to go 1, 2, 3, 4, and I'm going to plot my point right here. Now, in the rectangular coordinate system, what I want to do is I want to figure out how much distance am I going this way to get my x coordinate, and then how much distance am I going down so that I can get my y coordinate. And because our ordered pair is in quadrant 4, hopefully you can make the observation that x is positive and y is negative. So please keep that in mind as we are figuring out our ordered pair in the rectangular coordinate system. So what we want to do is we want to use these two equations to figure out x and y. So x is going to equal r cosine of theta, and our r value in this case is -4, and then we have cosine of 3 pi over 4. So we know that cosine of 3 pi over 4 is -√2 over 2. So this is going to be -4 times -√2 over 2. And if we simplify that, we get x equals 2√2. Let's go ahead and figure out y now. Y is going to be r times sine of theta. So that's going to be -4 times the sine of 3 pi over 4, we know on the unit circle is √2 over 2. And so that will give us y equals -2 √2. And notice that this corresponds with what we found earlier, that our x value should have been positive and our y value should have been negative. So that part checks off, and we identify here that this point on the rectangular coordinate system is 2√2, comma, -2√2. So that is our final answer for this example.